So let's first read the question. It says, in a national vocabulary test, it is known that the mean score is 68. Okay, so so what is this 68? It's the mean score in a vocabulary test, and they're talking generally. So this is the population mean. It's not referring to a sample. So it's the population mean that they're talking about. So here we have a class of 20 students. That 20 is n, the sample size. A class of 20 students takes the test and has a mean score. So here we're talking about a mean score of 64. And they are referring to 20 students who took the test. So obviously the 64 is not the population mean, it's the sample mean. Sample mean, the symbol is X bar. So 20 students took the test and the mean score is 64. So definitely that's not the population mean, it's the sample mean. And the standard deviation was 13. So when it says that the standard deviation is 13, notice that they're referring to the sample of 20 students who took the test and their standard deviation was 13. So in this sentence, it is clear that the standard deviation that they're referring to is the sample standard deviation. It is not sigma, because if it were sigma, they would be talking about the standard deviation in this sentence. So what is given to us is S, and it is not sigma. So sigma is the population standard deviation. So we need to know the difference between these two because it's very important to figure out whether we know sigma or we don't know sigma. So clearly here, we do not know sigma. We only know S. Okay. So, and how do we know that? Because a class of 20 students, they're talking about the sample. Is there evidence? So, clearly, we're going to answer this question with a yes or no. The minute the question is answered with a yes or no and the word evidence comes in, it's going to be a hypothesis test. Okay. So in the first step, we're going to state. If it's a hypothesis test, we start off with, we will find evidence that the average of this class is significantly different. So let's write down the rest. So this is what we need to write in the statement state. That's our first step of the 4-step process. We will find evidence that the average of this class is significantly different than the national average of 68. Our next step is formulate. So in the case of formulate, we're going to say, since sigma is not given. Clearly what is given is S and not sigma. It's referring to a sample. So since sigma is not given, we will use, since sigma is not given, we will use T procedures. If sigma is not given, we use T procedures to do a hypothesis test using the formula, and put parentheses when you do your calculations. T equals X bar minus mu O divided by S over radical N. Okay, so this is an important step because we are deciding which direction to go in, and use the final exam handout to figure this formula out. You don't need to remember anything. Next is solve. So if it's a hypothesis test, the first step in solve is writing down the null and alternative hypothesis. So the question says, a class of 20 students took this test and the rest is given. Is there evidence that the average of this class is significantly different? It doesn't say greater than, it doesn't say less than, it talks about significantly different. Okay, so mu equals the national average is your null hypothesis. Mu not equal to the national average. So based on an x bar of 64, x bar is the sample mean, we are going to prove that the average of this class is not the same as that of the nation, and that is the national average of 68. Okay, so next, remember that this is mu O. Mu equals mu not equal to, because it says different and not greater than or less than. So this is a two-sided test. Next, we calculate T, which is equal to x bar minus mu O divided by S over radical N. So we just plug in all the numbers. So we have 64 x bar minus mu O. Mu O comes from the HO and HA, so that's a 68, divided by S, which is a 13, divided by radical N. N is the sample size, and that is equal to, so use your calculator, make sure you have parentheses around the numerator and denominator, and you get negative 1.38. So now I'm going to switch to the table. I'm going to take this T value to table C, because we are doing a T distribution here, or T procedure. We go to table C. If N is 20, the degrees of freedom is 1 less. We need to know the degrees of freedom in order to find the, and look at this, two-sided p-value is what we need. So I'm going to switch to the table right now, and let's look at 19. We need and notice that our number is, sorry, that's not the one. So our number is negative 1.38. Negative numbers are not given in the table, but because of symmetricity, the p-value for positive 1.38 is the same as the p-value for negative 1.38. So just discard the negative sign and use 1.38. So 1.38, look at this row, number 19, because degrees of freedom is 19. So our number 1.38 sits in the middle here between these two numbers. We go down the column and our p-value is between 0.10 and 0.20. So how do we write our result? Let me just... Okay, so I switch back to... So our t-value of 1.38 lies between, write down the two numbers, and the two numbers are the smaller number is 1.328 and the larger number is 1.729, and the p-value lies between 0.10 and 0.20, and all this I get from the table. I'm looking at the two-sided p-values. Okay, so this is not good because our alpha we set as 0.05, so our p-value is larger than 0.05. A large p-value is not good. So basically, we fail to reject HO. We fail to reject HO. So our conclusion is we do not have enough evidence. And write down your p-value, which lies between 0.10 and 0.20, which is the larger number. Make sure it's in the right order, smaller first and then larger, that the average scores of this group is different than the national average. Finish the sentence, and that's your conclude part. So these are the 4 steps. Okay, you need to write down every single step clearly. State is write down what you're planning to do. The most important thing is to identify whether sigma is given or not given, and then whether it's a confidence interval or a hypothesis test. For a confidence interval, we are estimating the mean, but if we are trying to prove something, it is a hypothesis test. And we end with, we do not have evidence that the average of this class is significantly different than the national average of 68.